Hi viewers, welcome to LMS Solution. Today we are going to see about a neural network with the module predictive control of PMSM, that means permanent magnetic signals motor. So this is a sampling model for neural network with the model predictive control of PMSM. This model consists of the DC voltage source and then three-phase inverter. The three-phase inverter will be connected with the permanent magnet signals machine, and this PMSM receiving the torque input here. So from the PMSM we are measuring the different parameter. So here we are measuring the rotor angle in radian. So that going to be converted into electrical radian. So by using conversion of mechanical to electrical radian concept. And here we are measuring the stator current in phase A, B and C, and then here we are converting that phase that means stator current ABC in the DP knot form, okay, by using a power transformation. And here we are measuring the rotor speed in radian per second, so that is going to be converted into the per unit value. And similarly here you can see that here we are measuring the electromagnetic torque, okay, and then here we are measuring once again rotor angle, and that going to be converted into electrical degree, okay. And then here you can see that here you are applying that neural network controller, right? So neural network controller, we see two inputs. One is the error input, error nothing but that means the difference between the reference speed and the actual speed of the PMSM, and also it receiving the another input nothing but the reference speed command, okay. So neural network will be receiving these two input, the error speed and the reference speed, and then based upon that it will be generate the IQ reference. So here we are using a field oriented control. So here we are making ID reference equal to 0, and then we are taking output of NN will be considered as IQ reference, and here we are measuring the actual ID and IQ from this data current ABC, okay, and then it will be processed via model predictive controller, okay. So here you can see that this is a model predictive controller. So here we are going to consider that here we need to provide the detail of from that inverter and PMSO, and then here we are going to consider 8 states, right? 8 switching steps. That means it start from 0000 to 111. Okay. So initially the pulse will be is taken as 0000. Okay. That means the switching pulse for S1 to 6 going to be considered as 0, and then here you are going to calculate the cost function. So based upon the switching pattern, right? So here we created 8 switching pattern, right? So each switching pattern we are going to take and from here, and then based upon the switching pattern is CSP and SC. So we are going to calculate inverter voltage, right? So here we are calculating the inverter voltage. So down the inverter voltage we are going to calculate the VSQ and VST. That means we are applying that transformation here, and then based upon the VSQ and VST you have to calculate the ID and the EQ. So this predicted the direct axis current and the quadratic axis current. So after calculating that ID and IQ, and then you have to calculate the cost function for the different switching states. Okay. So after calculating that cost function for the 8 switching steps, right? So you have to short that cost function. So short the cost function from minimum to maximum. Okay. And then you have to find out the location. So which location? That means, for example, 8 state, right? So in 8 state, the cost function maybe go for a minimum for any one of the state from 1 to 8, right? So you have to find out the which state having minimum cost function, right? So here we are going to comparing that index value which is equal to 1. If the first index value which is equal to 1 means we are going to send the pulse here, this kind of pulse here. So based upon the index value, right, we are sending the pulse, okay. That means which index value having a minimum cost function. So that corresponding pulse will be going to be sent to that via the MBC controller, okay. So here we receive that pulse based upon the cost function. and also it's going to be trigger this three-phase inverter, okay, in order to control the PMSM. So here we are measuring the pulse of the uh, pulse for that three-phase inverter, and here we are measuring that uh, three-phase current, that mean voltage and current, that mean inverter voltage and current, and then here we are measuring the speed, that mean here we are measuring the actual speed and reference speed, and here we are measuring the electromagnetic torque of the machine, okay. So here you can see that I created that reference speed command. You can see that from 0 to 0.05 seconds, right, the speed will be starting this from 0 to 120, and then from 0.05 to 0.1 it will maintain at 120. After 0.1 to 0.15 seconds, the speed will be decreased from 120 to 0, okay. So based upon that, it going to be given the input for that neural network, okay. So before that we need to train the neural network. So for that we have the data. So here you can see that, so we have input output data. So this is input data for a neural network we collected, and then this is a output data so collected for the neural network. So this do data going to be used for train the neural network. So for that, to train the neural network, just to be the type and then start, and then just use fitting app and click next, and select the input and select the output, and changing to matrix source, and then click next and click next, and then train the model, okay. So train the model up to, you can see the R will equal to nearer to what, okay. So you can train the model up to R equal to, and that means almost equal to 1, okay. Here also you can see that number of iteration, performance, and gradient, and then different values with a new. So you can see that during training process of neural network, okay. So we need to try to optimize that, we need to reduce that performance, like mean squared error, right. So we need to reduce the mean square error. So that means that the difference between our input output data and then the output from that neural network should be have some minimum error. So for that, here we are consider mean squared error as a objective function. We are going to minimize that mean squared error, okay. So here now you can see that the training process completed, and then you can see that R value, right. So R value is almost equal to 1, and then you can see that mean squared error is almost 0, right. So we have 10 power minus 3, right. So that means neural network trying to help with the our input output data, okay. So click next, and then click simulate diagram, and then you can use this neural network for that particular simulating model particular application, okay. So this is where you are training the neural network, and then now we are going to test the model, okay. So for that I'm going to open the different scopes, okay, and you can see the different results here. So here you can see that the rate of speed, reference, and the actual. So you can see that the yellow color known as reference, and the blue is actual. And then here you can see that this is the inverter output voltage. This is the stator current of the PMSM. So this is the electromagnetic torque of the PMSM. And then here you can see that the switching pulse, okay. So here you can see that the reference will is affected at, that means tracked by the neural network, and also you can see that the MPC control, model predictive control, effectively control the three-phase voltage source inverter in order to control the PMSM with the for tracking the reference field command accurately. So we can see that idea or less that means during the change of speed, right, from the speed change from 0 to 120, you can see that it take maximum 15 amps on weekly amps, okay. So there is no that mean major variation in the stator current, right. So the system will be started very softly, right. So this is working of a neural network with a model predictive control of PMSM. So thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.